Good afternoon, everyone. On behalf of agricultureinformation.com, I welcome Ms. Preeti Singh, and she will speak on the topic biodegradable and compostable pack- packaging and dinnerware from Kansa grass. I now request the speaker to begin. Thank you.
Thank you so much, ma'am, for inviting me and giving this platform to speak about Kansa grass and its potential for utilization in the packaging industry. I'll start it with the problem statement that why Kansa grass is like a need to be used in the packaging industry. Like there is a packaging raw material and other biomasses are available already. So why do we need other biomasses to enter into this particular field? So I'll take this session with through a systematic way so that every doubt can had to be cleared. So I'll move forward. So in the packaging industry, like packaging industry is a most growing industry nowadays. People are moving towards industries are moving towards the eco-friendly packaging because this plastic problem is now going to become a crisis for the entire nation or entire world because plastic uh, as we all know the problem related to the plastic does not degrade. It took around thousands and 500 years to degrade a single plastic. So currently, and packaging is the segment where uh, it comes along with the actual product. If you order something or you take something, so packaging is the incentive. Like packaging will come along with the actual product and it suddenly act as a problem after the uses of the actual product. So packaging pollution is the pollution which is causing indifferently, like you are utilizing any product and packaging is an incentive as a pollution to that product. So industries and the world and the nation need the solution to that problem, and the industries are heading towards the eco-friendly packaging. Paper packaging is considered to be the most eco-friendly nowadays, so we are heading towards the eco-friendly packaging. In the eco-friendly packaging, we are considered that paper packaging and the bioplastics are considered to be the eco-friendly, but we barely knows that how is that paper manufactured, from where that paper is coming from, which we are using in the packaging or in any product or any industry. So this industry, the paper manufacturing is also having some problems related to the pollution, related to the deforestation, because maximum portion only this packaging industry contributes 14% to the total deforestation across the world caused due to the packaging industry. And this packaging industry is polluting as well. It requires 150 million tons of water, million liter of water per ton manufacturing of a paper. So by considering the problem of water consumption, energy consumption, chemical consumption, and the problem of deforestation, we need an alternative to that. And agricultural waste biomasses are the alternative, because agricultural waste biomasses has all that specific content which can be utilized in the paper packaging or in the packaging industry. In that agri waste, Saccharum spontaneum, that is a Kansa grass, and it is having another names related, that is regional names across the state, across the India. Kansa is in Hindi, Kansh, Bengali, Telugu, and Tulu, Relu, or Gadi. So there are many names. Its scientific name is Saccharum spontaneum. It is having a high potential to be utilized in the packaging industry because of its composition of in it, and also the fiber we produce using this Kansa grass is having a high strength, durability, and the uses in the packaging industry. Either it is in the single use packaging or in the premium packaging. So Kansa grass is having the specialty of it can grow on any poor, marginal, arid, semi arid land with the minimal requirement of nutrition, like minimal requirement of fertilizer and all. So it is easy to grow anywhere, and it is having a small harvesting period. Also it is having a fast growing perennial weed. So and the production of Kansa grass per hectare is 3 to 8 ton. Again, it is very high if we compare it with other agri waste biomasses available across the India or world. So it is a rapidly renewable. It can be harvested within a single, like 4 to 8 months is the harvesting period. It can be harvested twice a year. Naturally invasive and eco-friendly. So if we work on the packaging, converting this biomass into the packaging, into the biofibers, then these are some scientific data which we have worked on, that key the fiber length, how much is the fiber length, and how can we use it in the packaging industry, like the ideal packaging required, what are the what should be the technical specifications of the fiber that can be used for the packaging manufacturing. So this Kansa grass is having the fiber length which is suitable for packaging, fiber width which is suitable for packaging, and it is having a 69.2 holocellulose content, which is cellulose plus hemicellulose, which is the main ingredient for packaging. Pulp consists of cellulose and hemicellulose. If we go for the premium packagings or the high grade, high value packaging, then we separate hemicellulose as well. We use cellulose only, but for the packaging industry, for the normal packaging we use in our daily life, so for the tableware or for the dinnerware, so we can utilize cellulose and hemicellulose both. We basically need to disintegrate the lignin, which is the upper layer of the biomass, and free the cellulose and hemicellulose to utilize for the pulp and other products, dinnerware or tableware manufacturing. So how can we manufacture the convert this biomass to the pulp? So there are some processes in which treatment processes, but the conventional method are soda pulping, craft method are used to manufacture the pulp. Again, these methods are chemical consuming, water consuming, and energy consuming, because the whole continuous process of manufacture converting that agri waste to the pulp. And this is not only for the Kansa grass. This is applicable to all, because this is the only conventional method used to manufacture that pulp. So we initially do the pre-treatment of the biomass, harvest it, clean it, and chop into the required size if we are working on the agri waste biomasses. Then we do the soda pulping. We use caustic, we use Na2S to delignify the biomass, to separate the cellulose and hemicellulose out of it. And then we do bleaching for that whiteness in the paper, present in the paper. And then we go for sheet manufacturing. But again, at the initial at the inception, I told you that the problem with this method is that it is highly chemical consuming, water consuming, and electricity consuming, because we use chemicals at the part of delignification, and then we use water to wash that chemical to make it at the neutral pH and to use in the dinnerware industry. Because in the dinnerware we need the product which is suitable for human or animal health. So despite using this method, the research is needed to do at the part, like where how can we replace the consumption of chemicals with the microorganism or natural ways to degrade that lignin, and to convert that biomass to the pulp by degrading lignin naturally by using microorganisms or enzymes. But this process should be economic, because when we are working in the lab, we can make, without using a single chemical, we can make the pulp. But when we talk about going it at the large scale, at the scaling, at the commercial production, then the problem occurs, either at the cost perspective or at the scaling or the market perspective. So we have to do, if we are using the chemical degradation process, then also we need some optimization of utilizing, either we don't use chemicals, or we can reduce the chemicals, or we can replace the chemicals with the biochemicals, which again we need to manufacture to degrade. We need to do research at that part. We need to do research at the part of biochemicals that can act exactly as the chemicals currently used in the delignification process. So these are some of the applications. Like I initially told you, the Kansa pulp is totally suitable for packaging industry, for dinnerware, and creative utilities for books and other uh, uh, envelopes and bookmarks. The pulp which we manufacture using this Kansa grass is high quality pulp, can be utilized in various fields, from the packaging to the high quality filter papers. That totally depends upon the process you are using, of degrade process you are using, manufacturing that pulp, and the refinement you are doing of that biofibers to make it to any product application. So why only Kansa grass? We can use the agri waste, or we can use other wheat waste, like paddy straw, wheat straw, barley straw, cotton linterns. There are many agri waste products available in India. But why Kansa grass wins at that part? Because Kansa grass is having the ability to grow at the arid, semi-arid regions, as I have told you. Kansa is easy to grow, easy to maintain, easy to cut, and easy to utilize for the production and conversion into the packaging industry, because it is having lower lignin content, high cellulose and hemicellulose content. It is Kansa is having high yield in the pulp manufacturing, and is having the exact like fiber quality which Kansa has, is high quality which we get from the wood or which we get from the bamboo. So it competes with that biomass. So it is having Kansa grass easily available, easy to grow, easy to harvest. Second, the fiber we develop using Kansa grass is having high fiber strength, high the strength of the product we develop using Kansa grass. And the cellulose content is high in the Kansa grass, and the lignin is low, which we have to degrade is low, which we are required is high. So yield is high in the Kansa. It is around 50 to 55% of the fiber we get from 1 kg of. If we are treating 1 kg of Kansa grass, then we'll definitely get the 50 of 500 or 550 grams of pulp, which generally in the other biomasses yield limited to 30 to 35, or moreover to 40. Now, in the other agri waste like paddy straw, wheat straw, or in the bagasse. So definitely, plastic has to be replaced with the agri waste packaging, like agri waste pulp, because agri waste is having the potential to be utilized for packaging industry. Only the research is needed to work on the production process, how we need to produce the pulp from using any agri waste, and the packaging which we manufacture using any agri waste is like compostable, or it can easily be degradable in the soil, because currently we are working on the paddy straw, and we have worked on the Kansa grass as well. The product which we have developed, the packaging material which we have manufactured, was easily degradable within the time period of 15 to 20 days if we dig that inside the soil. So that is the quality of the eco-friendly packaging, if we truly making it eco-friendly. Currently the paper packaging we use, the paper packaging we receive, if we are ordering anything, that paper is having very harsh additives, and those are not easy to degrade. So currently in the and that the waste piles we see around our regions, around our cities, consist of 26% of paper waste in it. So we need to work on the paper packaging or eco-friendly packaging, but in a right way. Need to do the research if we are adding any additive to that particular biomass, any additive to that particular pulp. So we also need to think that, is it only increasing the durability, only increasing the malleability of that developed product, or it is degradable or not. It is going to enrich the soil, or it is going to release microplastics in the soil. So all these factors have to be considered during doing these research, and the research has to be done in a way that you are not doing it at only the lab scale. You have to implement it at the large scale as well. You have to scale the process you are developing inside the lab. So thank you.
Thank you very much, ma'am, for a wonderful
Thank you so much. Is there any question, ma'am, you can ask?
Yes, Grace. I think you need to stop share.
Okay,
My
I
voice
will
is
stop.
audible to you, right? Yeah,
Yes, yes, your voice is
yeah.
audible. Is there any
Okay.
question you can ask, please?
Yeah. I'll move on to the questions now. The first question is, what are the biggest technical challenges in producing biodegradable packaging at a commercial scale?
The biggest challenge is at like if you are using any agri waste currently, so the biggest challenge will lies at the raw material managing and raw material supply chain. If you commercialize, like we were working on the paddy straw, that is also an agri waste, but the major challenge which we have faced is rice straw is a seasonal crop. It will be like at some point of the year it is available, like hell, like people are burning it, people are throwing it, but in the second period of the year it is not available anywhere. So we need to maintain the gap, we need to maintain that we have to work on the storage, raw material supply chain. This is the first challenge we will face if we are working on any seasonal agri waste. The second challenge we'll face will be if we are not going to that conventional method, if we are not doing the conventional production, not opting the conventional production process, then we have to do some research at the part, like what should be the method of reducing the chemical consumption, because this industry is a chemical consuming industry, water consuming industry, electricity consuming industry, so the capex is high. So we need to work on the process, operational process as well, to reduce all these chemical, water and electricity consumption, and that can be achieved through the process optimization first. Second, the process innovation, like we are doing some microbial degradation, enzymatic degradation and all. And third third challenge we'll face is the chemical we consume during the production of the pulp. That chemical has to be like treated if before discarding it to the nature. And in the lab we are using a bit little amount of chemical. At the large scale this is going to be the 100 times or 200 times of that waste we are generating in the lab. So these are some of the challenges, and but all these challenges can be mitigated through the efforts, through the R&D. So because we have done that, so this is not an issue ki we cannot do that, but before implementing it anywhere or before going through we need to consider all these factors, like these are the challenges are going to be faced by any person who are going to be work in this particular field.
Okay. What is the decomposition time of your products and under what condition do they compost best?
We simply have dig a hole and put our product into it and uh, fill it with the soil again. And after 15 to 20 days, like we were checking ki it is degrading or not. After 2 days or 3 days, we come totally monitoring the product we have digged in. But it was, we didn't make any compostable conditions. We just simply wanted it to degrade naturally in the environment, because for the composting we need, if we are making a product which is compostable, plastic is also compostable, but for composting that product you need to collect it from the customer who have taken it from anywhere. So the collection mechanism in India is not very good. People used to throw it out anywhere. They don't throw it only in the dustbin. So collection of that product, utilized product, is very hectic. So I was working on the biodegradable product. Like it can degrade anywhere. If any person is consuming in a village and throw it out in the field, so it can degrade there as well. So but the composting conditions are not very harsh. Like they, if it is in the soil, it will degrade by itself within 20 to 30 days in the
Okay.
natural
How
condition.
cost competitive or okay.
Yes.
How cost competitive are biodegradable dinnerware products compared to conventional plastic or paper products?
Okay, so if we compare the competitiveness at the part of manufacturing only, so obviously plastic products are a bit cheap because of the manufacturing of that particular product. But if we add on the cost of utilizing that product on the human health and on the environment health, we are today we are using that plastic and we are eating our food in it. So the health issues we are facing right now, and we are going to pay it in the hospitals. So if we add that cost in the manufacturing or the purchase of that single piece of dinnerware, so it will the plastic product are more costly. But if we are only seeing that the manufacturing cost of the plastic product and the manufacturing cost of the fibrous product, so a plastic product will definitely be cheaper because of its mass production. But if we can level up the fiber product development at that scale, the competitiveness will can be achieved. And at that time, 20 15 to 20% plastic products are cheaper than the fibrous product because of these reasons.
Okay. Are there any government policies or startup incubations programs that supported your journey?
Yes, ma'am. Like I am supported only with the government schemes only. So I have started this journey from IIT BHU, and there I have selected for this Ministry of Agriculture program RKV by Raftar, which was specially for the startups who are working on pre-harvest products or on the post-harvest products. So I was working on agri waste. So that was at the ideation stage. They provide grant of up to 5 lakhs rupees. And if you break through the idea and reach at the marketing stage, then they will provide you fund of about 25 lakhs. So the Ministry of Agriculture from IIT BHU has supported me, and then I came to IIT Kanpur. Here I received the support from Department of Science and Technology, Startup India, Start in UP, and City CSR fund from IIT Kanpur as well. So I have received like a lot of support from the government and the incubation center, which is IIT BHU and IIT Kanpur.
Okay. What are the major barriers preventing a wider adoption of compostable packing in India?
Major barrier lies at this stage, like most people are not aware, and the repercussions of using plastic waste cannot be seen instantly. The repercussions take time. So the time of, like, if we are using plastic today, then the result of that plastic consumption I will see after 10 to 15 or like 5 years. So the time period is big. So at that time we do not consider it because of use, like I was using 5 years back, continuously using this product. So the first problem is awareness. People are not aware enough, like they can what they need to use and why they need to use that. Why, what if they are switching towards fiber packaging or compost, like tableware, fiber made tableware, so they do not know why to switch at that, because easily available thing is plastic, or plastic packaging, plastic dinnerware, tableware items are easily available. So they do not know why to switch towards that. Despite knowing all the health implications or all the implications of plastic consumption, they are not switching towards that. So first cause is lack of awareness. Second is obviously the cost, because that is cheaper. If it is cheaper product available in the market, they'll definitely go for that, unless they are aware enough, like the cost of using that cheap product is way more high, like they are spending that money to the hospitals and to reducing their efficiency and generation. So if they'll consider all these factors, they'll definitely switch towards it. But currently lack of awareness and lack of availability as well. Like fibrous
Okay.
products are not widely available across the India, and currently those products are available. They are also chemically treated. So people are not aware enough ki what they are consuming, how much cost that consumption is implementing on their health as well as to the environment.
Okay. How do you ensure that biodegradable products remain food safe and durable for practical use?
How am I ensuring that our product is food safe? Like, this is a question.
Yeah.
Yes. So we do the third party testings. Currently, we are manufacturing this pulp only, and we are selling that pulp to the industries who are already manufacturing those packaging or those tableware items. So whole the all the testings we are that the testings are required to make it suitable for food grade packaging, food grade industry. All these testings has been done by the third party, like they are doing it, they are giving the green signal that your product is safe to use. So we are selling a product to them, and they are giving all the criterias, on the criterias they are required, and they are giving us the red green flag like your product is safe, we can use it in the packaging or tableware industry.
Okay. What advice would you give to young entrepreneurs interested in sustainable materials and green manufacturing?
I'll only say he just work on it because it is the requirement of the, like, it is going to be the future. You have, if you are thinking working on it, you definitely have to start. I'll definitely say just do some analysis of your product, whole analysis, like you are going to start from here and where do you want to end up. So just and in mid between the journey, what are the stops you can get and what are other obstacles you can get. Just do a whole research and then definitely start working on it. And uh, if you are having any idea, so I'll say there are many supportive supports are available uh, in across the nation. Like there are incubation centers, there are other entrepreneurs who are working on it, there is data available online. Just do research and start working on it because it is the need. But and just do not work because you are seeing an returns into it. Just consider all the returns, like consider the requirement of that research and start working on it.
Okay. Can biodegradable dinnerware truly replace single-use plastics in large-scale events and food industries?
Sorry, can you please repeat the question?
Can biodegradable dinnerware truly replace single-use plastics in large-scale events and food industries?
Okay, so you're asking that can this biodegradable
Yeah,
tableware or dinnerware can
whether it
replace
will be
whole.
replaced with single-use plastics.
Yes, it definitely can replace single-use plastic, because single-use plastic, we need to see that where are the single-use plastic has been used, and are we imposing a lot more cost of using that single-use plastics? If we do not use that plastic, what are the alternatives we can use? So we need to work on that. Definitely, it is possible to replace that if we are working on it and we can produce a product which is fulfilling all the requirements which currently the plastic is fulfilling, then definitely it will replace the single use plastics in the packaging. At least I can say that the packaging, single use plastics in the packaging can be replaced by the biodegradable packaging which we can manufacture using the agri waste. And the raw material shortage cannot be seen because India produces enough agricultural waste that can fulfill the requirement of paper packaging in the India, because currently around 8 to 10 kg or 18 to 20 kg of paper has been consumed by every person as per the data. Like every person's requirement is around 18 to 20 kg paper. So that can easily be replaced by using the agricultural waste available in India and the Kansa grass to convert that waste into the biofibers and convert it into any packaging product. So definitely it can be reduced, but with the proper research, with the proper segmentation of the product, with the proper placement of the product.
Okay. What quality standards or certifications are required for biodegradable food packaging products?
Okay, so currently, like biodegradable, if you're working on biodegradable food packaging, so definitely FSSAI's certifications are required. But before that, the pulp standards, we need to meet the pulp standards that are very important. Uh, that can be achieved from the CPPRI Saharanpur in the Uttar Pradesh. That can be achieved after manufacturing the pulp. You need to go through some testing and testings, which can give your fiber strength, which will give your fiber water retention time, which will give your the consistency of the pulp you will develop. And those all factors will decide like either your pulp is suitable for food grade industry, food packaging, product manufacturing or not. And after that you will get certifications from FSSAI organizations, and your product will be food safe and can be utilized for food grade packaging industry.
Okay. How do you maintain consistency in raw material supply and product quality throughout the year?
How do I maintain it?
Yeah.
Okay, so working solely on this big project is not possible, because you have to maintain the raw material supply chain, you have to maintain the operations, you have to do the technical research, you have to do the marketing and logistics after for selling that product from your industry to the customer organization. So there are many blocks are involved in your working. So the raw material supply chain and operations part, we are doing this with the integration of an organization like farmer producers company, farmer producer organizations. We are working with the farmers because they are the main stakeholders of that particular waste. So why to go with to the other persons if farmer, we can work directly with them. So currently we are working with the FPOs. FPO used to take care of the raw material supply chain. They do the collection of that particular biomass, store it, and I just collaborate with them, and I just tell them my requirement like 5,000 tons per year, 4,000 ton per year. Like if my monthly requirement is 300 tons per year, I have told them. They used to deliver that product to my organization, and we'll do all the operation part. And also we do collaboration with the farmer producers company, farmer producer organization. They have their collaboration with the farmers at the village level. So they used to collect the biomass. They have all the machinery they have all the equipment to collect that waste. So this collaboration, the collaborative approach make the process easier, make the operations easier.
Okay.
So currently
What
I am working like that.
okay.
Yes.
What kind of machinery and infrastructure are needed to start a small scale biodegradable dinnerware unit?
Okay, so I will just ask a question. Biodegradable dinnerware unit only, or an integrated pulp production and the product development, like an integrated
You can
unit?
share both. You can share both.
Okay, so if you are working on biodegradable only dinnerware, you are not working on the pulp, then there is like already available machinery sets in the market. You can talk to any industry who are working in this manufacturing units setup uh, to implement it for a dinnerware. Like you have to tell your version, like you want to produce 500 kgs per day, 700 kgs per day. They'll give you a quotation like this is the machinery cost and this much area is required, this much electricity is required, just implement it and you will start the production. But if you're working on an, if you want to implement an integrated industry, like you'll, but for a non-integrated industry, like if you're only producing the tableware or dinnerware items, you'll have to do a collaboration with the industry who will give you the pulp. because the raw material you are required is the pulp. You have to purchase it from the organization. At that point, you have to decide a location from where the pulping and the pulp availability is easy. Otherwise, you'll have to pay a lot of cost at the logistics uh, making the availability of that pulp from that organization to your unit. And if you're working on the integrated unit, like you're going to produce the pulp at your space and you're going to use that pulp for product manufacturing, then you will have to set up two industry, first for the pulp development and then for a product development. So for the pulp development, you are required raw material, as I have told you initially. And for that pre-treatment, cutter, chop shaft cutter, where washing of that material, and after washing, you'll go for, if you're opting for soda pulping or normal conventional pulping, then you'll require a continuous digester or batch digesters to uh, digest or degrade that biomass, to degrade the lignin available in the biomass. Then you will have to do the refining of that developed pulp, then the washing, and then sheet making or using that product for the product dinnerware development. So this is a long process for manufacturing, but we can, like as I've told in the presentation as well, we can optimize the process by optimizing processes at every step. You have to study every step to optimize that process. Like iska the implementation cost of pulping industry was, like when I was about to implement it, it was around, like the quotation, initial quotation I have received for 15 tons per day capacity plant was costed us around 25 crore. So, but we did not have that much amount of money. Then I had started working on the plant design, like how can we reduce that cost up to 50 lakhs to 1 CR, because that much amount we have only. So I have worked on the every single part of the machine, every single process, and optimized the process and reduced the cost up to 50 lakhs. And it is in between 50 to 1 CR. So the initial investment will be high, but you can reduce it by doing a proper research and proper analysis of every step.
Okay. Are your products microwave safe, water resistant, or suitable for hot foods and beverages?
Yes, definitely. Microwave safe, I cannot uh, comment on that because we currently haven't tried it on microwave. But the industry to which we are supplying a material to them, they are using it in the microwave, and they have said that it is a microwave safe. It is fully safe if we are using a hot food in our plates or in our developed product, because it does not have any layer, plastic layer in it, or we do not add any additives like which contains plastic or any plastic material, because currently we are selling a product to Europe, London based company. This is a London based company, so they have like a large technical data approvals. So they have done all the initial testing, like our product is food safe or not. So it is water. For water resistivity, you have to add some additives, but there are some food grade additives that can provide water resistivity, oil resistivity, and the microwave safe, to make your product microwave safe. So there are some additives which definitely you have to add at the uh, stage of product development, dinnerware development. So there are additives which you have to add.
Okay, thank you very much, ma'am. We have now completed the round of questions. On behalf of agricultureinformation.com, we'd like to thank Ms. Preeti Singh for the talk and for answering the questions. This meeting will
Thank you
now
so
be
much, ma'am.
closed.
Thank
You're
you so
most
much,
welcome.
ma'am. Can I leave the meeting now?
You're most welcome. Yeah, please, ma'am, please.
Thank you so much.